Okay. I guess I can't really say good morning, maybe. I don't know. Who just woke up? Who didn't wake up yet? Okay, that's all reasonable people. I can totally get that. So my name is Magnus Hagander, and I'm here to talk to you about Postgres 10. You've probably heard of this Postgres thing. Does anyone in here not know what Postgres is? You're lying. At a conference like this, you kind of expect everybody to know what that is. But you don't know. Who has met this guy, the now decapitated Slonic? It's only temporary. It's one of our mascots that we use in Postgres Europe. This is actually from the FOSDEM conference in last February. And that's the elephant head in Steven's bed. So, let me turn that on. So, as I said, my name is Magnus Hagander. I work for a company called Red Pill Info. We're an open source services business in Scandinavia. I'm based in Stockholm in Sweden myself. Thus, I totally get it for those of you that want to go back to sleep. In Postgres, I'm a member of the core team. I'm one of the committers who write the code for the database or review other people's code, or at least I'm supposed to do that. Feel free to bitch at me for not doing enough of that. And I'm currently the president of the board for Postgres Europe. But enough about that. Let's talk about Postgres 10. So who's already running Postgres 10 in production? Anyone other than me? Oh, come on. It's been out for a while. Okay, who's running it at all? Okay, a little bit. So Postgres 10, it's this whole new magic thing. It's a new era of versioning, right? Did you know that there is no dot in Postgres 10? Because apparently the way that we've been doing, like Postgres has had versioning that looks like this. We had 8.4, and then we had 9.0, and blah, blah, blah. We got to 9.4, 9.5, and 9.6. And this is apparently very, very complicated. Because it's a sequence of numbers, but there is also a dot in there. And that makes it very complicated for people. So what we're going to do is we're going to remove the dot. And the next one is going to be Postgres 10. It's not going to be Postgres 10.0. So when we went from 8 to 9, we went from 8.4 to 9.0. We're now going from 9.6 to 10. Notice there is no point. And the next version after 10 is going to be 11. And then 12. And you can probably figure out what comes after that. Now this is eventually going to be a problem. As you heard in the keynote, we did at one point have a version called Postgres 95. And when we get to that, there's going to be a problem here. But I really do not intend to be involved in Postgres releases at that point, since we release about one version a year, so that's going to be somebody else's problem. Obviously, we also have our minor versions, and we're going to keep working with that. So we had 9.6, we had 9.6.1, 9.6.2, so there's actually going to be a 10.1. But that's the minor version. Right, so there's going to be 10.1, and there's going to be 10.2 and 10.3 and whatever, as many as we need to fix bugs along the usual schedule of at least once every quarter. There will be a new minor version. They're going to be the second number. And of course, this is the part that was actually confusing to people, right? It's the fact that we had 2 dots in the number. It was no longer a decimal number. So we won't do that. Now, if you're actually querying the APIs in Postgres from your application to check versions, this is actually going to be reported as 10.0.1 and then 11.0.1. It's just the middle thing is always going to be 0. It's not going to change. This is obviously the most important thing, right? This is going to break most. No, it's not. But it's going to take, I mean, the amount of time I've spent working with our customers or with our customers' other vendors trying to explain how Postgres versioning works is actually ridiculous. You'd think it's an easy thing to explain, but then you get all these like certified software that says we work with Postgres version 9. And for those of you who are using Postgres, no, there's a little bit of difference between 9.0 and 9.6. Especially if you write this at the time of 9.2, and 9.3, 4, 5, and 6 didn't even exist. But they certified that they worked with them. So we're hoping to fix that problem. So let's move on to how we're doing this. The Postgres 10 started its life about a year ago. It started in August of 2016 when we branched 9.6. So the way that we work in Postgres is the next version is built on the master branch. And then we branch off stable branches. So right now we have a stable branch for 9.2 and 9.3 and 9.4, 9.5 and 9.6. So what that means is in August 2016, we branched 9.6. That means that the master branch switched to be Postgres 10. And we had actually done the byte shedding, so it was version 10 already. We haven't changed our mind this time. And then we work in Postgres with something we call commit fests, because everyone has their own name for doing more or less the same thing. It's the iterative development model that we use in Postgres, where the idea is we basically spend 1 month writing features and submitting features, and then we spend 1 month reviewing and committing those features. At least that's the theoretical idea of how these things are supposed to work. So we had 4 of these. We had a commit fest 1, 2, 3, 4, and 5 in September, November, January, and March. In theory, they were all exactly 1 month long. That's not how reality works, but we try. In May, we put the beta 1 version out. In August, we put the beta 2 and beta 3 versions out. So beta version is out. Please test. If you haven't already tested the beta version, now you know what to do in the weekend. But in particular, hopefully your systems have tests. Please take Postgres 10 beta in your testing environment and run your own tests against it, the test that you already have, to let us know if we broke something, because we probably did. And maybe it was intentional, but it's also quite likely it was not intentional, in which case it's much easier to get this fixed before we release than to wait until after. But let's get into the actual new features. What do we have in Postgres 10? I do these talks for every version. I always have a little bit of trouble trying to figure out, you want to break it up into sections, but what are the sections? So I've decided to just go into DBA and administration. I made monitoring its own section, even though in fairness that's kind of part of the DBA side. And we got developer and SQL, backup and replication because everybody loves that, and performance because nobody really wants their server to be slower. They want everything to be faster with every new version. So we're going to go through these in order. But before we get that, let's go to first things first. And I thank the people whom I was part of, I guess, for the decision that maybe finally I get to use one of these in my slides, right? Welcome to Postgres 10. If any one of you has ever written any sort of maintenance script for something in the database, it is probably broken now, because we made some small changes. We'll start for number 1. We've dropped support for Postgres protocol version 1.0. That means if you have Postgres clients older than version 6.3, they no longer work. Who has been using Postgres since version 6.3 or longer? Maybe half a person in the back, yeah, and me. But 6.3 is a long time ago. If you lose out on that one, you probably have already got a problem, you just don't know about it. But it's been around for a long time. We've also dropped support for floating point timestamps. Now, back in the days, Postgres used to store timestamps, all the timestamp data, timestamp with time zone, all these things were done in floating point because our computers didn't really have 64-bit integers. Yet, does anyone have a server that does not have 64-bit integers today? I bet not. But the point is, this is actually still relevant that we drop them now, because if you have a cluster that's running with floating point timestamps today, you can't PG upgrade that to Postgres 10, because Postgres 10 does not support this anymore. I know of people who are going to get bit by this because they've been continuously rebuilding Postgres manually to use floating point timestamps simply in order to be able to use PG upgrade. Now they can't do that anymore. Now they're going to have to upgrade in a different way. But again, this is not likely to break a lot of things. So we've broken some more things to make sure we can get to all of you. The pgxlog directory does no longer exist. It is now named pgwal. And likewise, the pgclog directory does no longer exist. It's now named pgexact. This means that if you have written any sort of backup script or anything manually, you hopefully followed the instructions which said don't back up pgxlog, so your backup script is now broken and you have to update that. Of course, the right way to update that is to use something like backrest or barman instead and stop writing your own scripts. And they are both updated to support Postgres 10. The reason for this change, which is the underlying change of a lot of the breakage, is that far too many people would run out of disk space, go look at their Postgres directory and say, hey, here's this big directory called pgxlog, and it's just log files, so I can delete those so I get more disk space back. Or pgclog. And you do that, and now you no longer have a database. This is the underlying reason for this change. It's insane how many people did that. And yes, anyone who's upgrading now is going to pay the price for those people, but over the years, we do believe that that's going to actually pay off, but it's going to be kind of a pain point. Now, this is reasonably easy, so we figured we'd also change some functions. There's no longer a pg switch xlog. It's now pg switch val. There is no pg xlog file name. It's pg val file name. There's no pg current xlog location and insert and all that stuff. It's all now val, pg current val. pg xlog location diff is now pg val location diff, right? Basically, every single function in Postgres that contains the word xlog has been renamed. So you can grep your code base for anything referencing that, and you know you will have to change it. Now, they still work exactly the same. They've just been renamed. And we've changed some. The pg receive xlog does not exist anymore. It's now pg receive val. pg reset xlog, who I'm hoping none of you ever have to use, because that means your database is already screwed, is now pg reset val. And pg xlog dump is now pg val dump. I mean, we must have caught most of you with something now. Okay, let's do one more. pg base backup had an xlog method. That's now val method. And xlog dir is now val dir. And for all the other command line tools as well, anything referencing xlog now references val. And that's not really the last one. We broke some more things too, but we can't spend this entire talk just talking about what we broke. But do know that when you upgrade to Postgres 10, many of your small maintenance scripts and all those things you run will break. They will be easy to fix, but you will have to fix them. Okay, so let's move on to some good news. Important new features in Postgres. And also one to notice. Many of you probably, you read your server logs, right? Everybody reads their server logs at regular business. And you notice every time you start Postgres, it writes this little message saying, protection against multi-exact wraparound issue has been activated. Right? That message is no longer printed. But don't worry, we did not remove the protection. That's still there. The message is gone. It's actually downgraded, so if you run it in debug logging, you will still get it. So yeah, don't be scared. I've seen that in other cases where messages that everybody thought was just spurious information message, and you removed it, and people got really worried that this thing was actually turned off. So it's not. Okay, let's take a look at the actual features, which is probably the reason why you decided to come to this talk. And let's start looking at the DBA and administration. Now, so who in here would consider themselves to be a DBA? And developer. What else? DevOps, sysadmin, sales, marketing? Nobody. Anyway, it's kind of hard. What's the difference really between a DBA and a developer? I do sincerely hope that none of you work in an organization where you have this, the traditional DBA, the guy in the machine room with the white lab coat kind of thing, who you had to go pray to get access to your data. So my general split is more like DBA are things that are around administration. Developer are things that are exposed at SQL level. Obviously, these are all interesting to both sides. So one big change on the DBA and admin side is that Postgres now supports something called SCRAM Authentication. We already support many, many different authentication types. Some of them are very nice and very secure, like Kerberos or SSL certificates and all that stuff. Some of them are less than awesome, like the default one that most people use, which is MD5. Actually, the biggest problem with the MD5 authentication is not the fact that it's MD5, which is not the strongest hash today. It's how it's done, it's how the salt is handled, it's how things are stored. Basically, if you steal the PG auth ID table of a server, you can replay, you don't need the password. You can replay the hash and get logged in, things like that. So to work around that, we've implemented something called SCRAM, which is a salted challenge response authentication protocol. It's a standardized protocol. Right? It's what a lot of people use these days. It is more secure. It works the same way for most people. Like your application, it looks the same. It's a password prompt. It's just that the password exchange and the password storage is much more secure. We default to a much more modern hash than MD5. I think it's ended up being SHA-256. But it's also like how the whole protocol works around that. And it will support upgrading these hashes in the future in a compatible way. You should be using SCRAM if you can everywhere. Like, it's better than MD5 in every possible way as an authentication method. There is no downside. except you need your clients to support it. And obviously, if you have a client running with libpq from Postgres 9.5 or 9.6, it's not going to work. For libpq, it's easy. Just make sure you install the one from version 10. You're going to be needing to upgrade your JDBC drivers to the latest version. You're going to need to upgrade your .NET drivers to the latest version to get the SCRAM support. But I would suggest, unless you really are on a very well-trusted network, in which case, good luck with that. Do look into getting onto SCRAM as soon as you can. Maybe not on the day of release, on the first thing, but put it on your plan to switch your authentication over to this, unless you are already using things like Kerberos, which is arguably even more secure, or SSL certificate, if done right, are arguably even more secure. But MD5, once your clients are up and capable of speaking SCRAM, there is no need to use MD5 ever again. It provides no advantages. We have some other simple things implemented at the libpq level. We support multiple host names in your connection strings. And the good thing about these things being in libpq is they will apply to any driver that's built on top of libpq, which is most drivers. So if you're looking at the Perl driver or the Python driver or things like that, they're all sitting on top of libpq, so this will work in them too. So in your connection string, you can now say things like host equals pg1, pg2, pg3, user and password. It will then connect to pg1 if it can. If pg1 isn't there, it'll connect to pg2. pg2 isn't there, it'll connect to pg3. If all of them fail, that's when your application sees a failure. Obviously, this is not a replacement for a full cluster with transparent failover and things like that, but it solves the simple case in a very simple way. You don't need cluster management or anything. That stuff will just work. And there is a new parameter you can set to this as well, which is you can request a writable host. So you can say host equals pg1, 2, 3, and then you say target session attributes equals read write. Then it will connect to these machines in order until it finds one that is not read-only. So if your pg2 happens to be your master and 1 and 3 happens to be the standby, it'll connect to pg1, realize, oh, this is a standby, and it'll reconnect to pg2 and give you a connection to an actual writable node. Which is, again, it's not a replacement for full-on clustering, but it solves a lot of the simple cases in a very simple way, because this requires no extra server. It's just a configuration. You need to add some commas into your configuration files. You can also now override where your PGPass file is. So if you store your passwords client-side, because sometimes you have to, we default to storing them in your home directory in the .pgpass file. Well, you can now just override that by saying pass file equals and point it somewhere. So if you're like shipping applications within your organization, you want to point to a shared password file somewhere for them to connect to the database, you can do that. Again, it's all about simplification. These are not solutions for the security-minded. These are solutions for not putting trust in there. Because please don't put trust in your authentication. That authentication method is just not good. Continuing off the DBA side is monitoring, because really monitoring is part of DBA, but we'll give it its own point because there have been some fairly major things done around monitoring. It's been too long since we broke your monitoring scripts. Haven't really done that since 9.2. Who had a monitoring script broken by 9.2 when we renamed the field procpid to PID? Yeah. Who had a monitoring script that didn't break? Really? So it's time. The thing that we do this time, well, we've done a couple of things. Our while sender processes now show up in pgstat activity. So previously, if you looked in pgstat activity, all you would see was your regular Postgres connections. Now you will also see the replication connections. Obviously, they're still also in pgstat replication. But the difference being, if you see one here, you see this new field called backend type. Didn't exist before. It says backend type equals while sender. That means that this is a replication connection. It will have database ID and name null. You would not see database ID and name null in pgstat activity before, so that might break your scripts. That's all good fun. But also simple, if you did a select count star from pgstat activity and compared it to max connections to see if you had enough, then that's going to give you the wrong number. You should not be counting your while senders in that. They count against max while senders. And in fact, that's not the only one. We also added all the background worker processes to pgstat activity. So you now see your auto vacuum launcher, background worker, writer, checkpointer, while sender, while writer, they're all in PG stat activity. They're all with the database ID being null. But they all have a PID so that you can look them up outside in your operating system. Going back, they all have these wait event and states so you can see what they're actually doing, which is obviously the reason that we want them in here. If you look at your regular backends, they're all going to be backend type equals client backend. That's what we used to have. Everything that doesn't say client backend is new. So if you want to look at your account star and compare it to Max connections, you go look at client backend. So we can see here also background workers will get a name. So the background worker here is a logical replication launcher. Previously, background workers they had names, but you couldn't really see them from within the view. So this gets you access to more information about all these processes. The other thing done to PG stat activity is that we have many more new wait events. So you can see what your processes are blocking on. We show all latches in wait events now, meaning small things. We can see extension things. We can see if your backend is waiting for network traffic. You can see if your backend is waiting for a timeout, like if you're running the PG sleep function. We can see I/O events, so you can see that this backend is currently doing a read. It'll tell you that. It'll tell you what kind of read it's doing, like what type of file. It won't tell you exactly which file, but it'll tell you what you're looking at. Like this one is writing to the transaction log. What is it doing? So it gives you a much more detailed look into exactly what is happening. And obviously being able to see this for the background processes as well is one of the reasons that the background processes were added to PG stat activity. So these will all give you a much deeper ability to see what your system is doing without having to break out the debugger or something like that, because we really shouldn't be doing that in production. We've also started the work. It's not done yet, but there is a number of monitoring roles that have been added with the idea of being, in 9.6 and earlier, we have a pretty serious problem in monitoring in Postgres, which is there are a whole bunch of things that require superuser. And you really don't want to give your monitoring system superuser, because superuser can do many, many evil things. So for that reason, we have a couple of new roles that you can just grant. So you create a user for your monitoring system, and you grant these roles to the user. For example, there is one called PG read all settings that can, well, you can probably guess it, can read all the settings, even the ones that previously required superuser. Now, these can be security-sensitive settings. If they weren't at all security-sensitive, we'd just let everybody read them. But it's a whole lot better than superuser. We have a PG read all stats that can look at all the statistics from your tables and all the analytics around them and all the distributions and things like that. Yeah, that can also be security-sensitive data, but it's still a lot better than superuser. And we have a PG stat scan tables, which lets you do things like PG stat tuple on a table, which can generate massive read loads across your system and take locks and things like that. You don't want anyone to be able to do that, but your monitoring system might have to do that. And the only previous choice was superuser, and we do like to get rid of any requirements to use superuser. There is also a PG monitor role, which basically just includes the other three. In upcoming versions, like 11 and 12 or whatever, there might be more monitoring roles, and the general idea is PG monitor is going to end up with all of them. So in the simple case, just grant PG monitor to your monitoring system. If you don't want to go into like the detailed level, it will still be a huge improvement security-wise over what you are hopefully doing now. Because if you're not running your monitoring as superuser today, that unfortunately means you're not monitoring everything that you should be monitoring. Unless you did the thing that we could do previous was, you created your own function that ran a select, and then you made it security definer and all that stuff, and nobody ever got that wrong, I'm sure. And nobody wrote one of those security definer functions that in itself had a security fault. Okay, let's move over to some of the more SQL exposed features. And there's been a lot of things happening in Postgres 10 in this area as well. One thing we've added is what's called transition tables. If you're working with triggers today in Postgres, you can make a row-level trigger that runs for every row, and you can see the new and the old version of the row as an update happen, for example. Transition tables basically applies this to statement-level triggers. So you can access the old and the new data as virtual tables from inside of your trigger function. So you don't have to run the function once for every row. You can run it for the statement and see all the changes. The syntax for this is, I believe it's from the SQL standard as far as you can get. We do use trigger functions. They look slightly different. But you say something like this: I create my trigger after update, and then you add this is the new magic keyword, referencing. So you say referencing new table as my new table. So we get a virtual table called my new table that will contain the new versions of every row. And then old table as my old table, and then we'll get a virtual table containing the old versions before the update of all these rows. They will only contain the affected rows. They won't contain the whole table, but they'll contain the actual affected rows. And then, again, for each statement execute procedure, that procedure will then have access to these two new virtual tables. And you can do just one of them. You can say, I don't care about the old ones. I would just want new table as my new table. Then you get just the new table. So you can do that. And that gives you ability to do things you simply couldn't do before. You might have had scenarios, I've certainly written code for that myself, where you had to have a per statement trigger that collected all the changes and put them in another table. And then you had a per row trigger that collected them into another table, and then a statement trigger that picked them back out of there. And yeah, it could get ugly. This can simplify a lot of those cases. We have some other SQL standard features added. We now have support for standard identity columns, which is basically how the standard does with what we've called serial in Postgres. It's what you have, it's auto-increment in MySQL, it's identity in SQL Server, things like that. The standard says, instead of saying column A, serial, you say column A, int generated by default as identity. Because it's the SQL standard, so you have to type more. But what it ends up doing is it creates exactly the same thing. It still creates a sequence, and it connects them together, and it uses the sequence. It does fix a few things. For one thing, you're now using standard syntax, not Postgres specific. But it also fixes this permissions gotcha that we had, which I'm sure many of you have run into. You have your table with a serial in it. You grant somebody else insert on the table. They do an insert, and they get a permission denied on the sequence, because you also had to grant update on the sequence. Now, if you use these, you don't have to do that anymore. System will take care of that for you. You can also say generated always as identity. If you do that, and then you try to insert with an explicit value in the column B, you will get an error. Today, you'd have to actually build a trigger to do that, to make it, otherwise you can override the value from a sequence. By specifying always, you can't override the value from the sequence. Except there is a keyword you can add to it to override the override. But just don't do that. That's just making it unnecessarily complicated. Some smaller changes on data ingestion side. The file foreign data wrapper, which if you don't know about it, it's the foreign data wrapper that lets you map a CSV file as a table in Postgres that you can use just like any other table. It now supports programs, so you can actually have the output of a command be available as a table. So every time I do a select star from test, Postgres will run this command, parse the output as CSV, and make it visible in my table. Now, if you're just going to do this, this is probably not the most efficient thing in the world. You might just want to load that data into the table. But if you have something that collects data from the outside and can provide that data in a CSV format, you can just plug it in immediately as a virtual table in Postgres and have that work. Obviously, this thing is going to run as the owner of the Postgres process. So you need to be careful about the commands that you let it run, because it's a potential for doing really bad things security-wise. So who in here would consider themselves working for an enterprise company? Not that many. Do you work with XML? No, then you're not really working for an enterprise company. At least not a modern one. You might still be on these Edifacts and stuff like that. For those of you that work with XML, we have now more or less support for the SQL standard XML table function, which will make your life a lot easier and your scripts a lot faster. Basically, you can take an entire XML document, you specify mapping rules, and it comes back out as a result set, as a virtual table. Previously, you'd have to do each column itself with its own XPath and things like that, and it would actually reparse the document for each column, which is not exactly excellent for performance. So if you are ingesting XML data, this will be a huge improvement for you. If you are not working with XML, this is not a reason to start. There are good and bad things about XML. I'm sure someone will tell me what the good ones are at some point. Well, there's a lot of data in XML formats out there that you just need to deal with. And this will make dealing with that data much easier. For those of you who are, more like hipster startup land, you're all obviously using JSON, right? But we have some things for you too. We now have support for full text search in JSON documents. And in JSONB, of course, which is what you're probably using. It makes a JSON-aware full-text search and a working TS headline for this. So as an example here, let me see if I can get this right. If we do a 2TS vector on a JSON, this is what would happen if you did this in 9.6. If you do a 2TS vector on a JSON field, it'll process it as a string. So if I take this document, which is foobar, and bas3, it'll index this. Like, these are the things that will end up in your full text index. If you do this in Postgres 10, which would be the same as like casting it to JSONB, in 10, it'll actually only get this one, because it only indexes the values. The value 3 does not belong in full text index. And the same thing, if you do TS headline, which is the one where you highlight the search hits, in Postgres 9.6, you get something nice like this. You search for this, it actually highlights it in the key, which means your JSON document is no longer having the same key as it used to have if you happen to search for a value that was present in a key. If we do the same search here, it will know that, oh no, foo is a key. I'm not going to change the key. That's actually part of the structure of the document. But if I were to search for bar, I would get the highlight within this value. So it's basically like it just knows how to extract the interesting parts from your JSON document and index those. Obviously, you also end up not, because if you have a structure document, you might have this foo field on every single row in your table and bloating your TS vectors with that. Once you're beyond that, it works just like all the other full-text search. If you create custom dictionaries and all that stuff, just works. It's just sort of a layer in between them to convert it into a workable format. Next feature, really useful for developers, except most people in this country don't give a crap, is we have support for ICU collations. Realize that this whole world outside of ASCII and emoji, which I guess is what we use over here now, we get a lot of more choices for collations. Postgres today, in 9.6 and earlier, uses the operating system collations. So whatever is on your Red Hat or your Debian or your Windows or whatever, that's how we deal with it. So collations, we're talking about things like order by on text. We're talking about uppercase and lowercase. These things that are so simple in the world of ASCII. And they're not as simple in the rest of the world. Because there are very, very, very strange rules. Now, ICU is a system that has a huge number of rules for how to deal with this in different languages, in different versions of the languages, in different versions of the versions of the versions of the versions of the languages, and all of these things. And we can plug it into. So that's one of the things, we get a lot more flexibility. The other thing that we get is ICU collations can be stable across operating system versions. This is a problem that you can have today. If you upgrade your Red Hat, for example, from, and I think this is a real case, I think it was when you upgraded from Red Hat 5 to Red Hat 6, the German collation changed, which means that all your indexes were silently corrupt. And there was really no way to find that out until you found that out. This doesn't happen too much. It happens fairly often with smaller collations. It just became very noticeable when it was German. The difference here being ICU is stable across versions of your operating systems. It's stable across versions of your Postgres. It's not stable across major ICU versions, because at some point they have to change it. There might be a bug in it. But when that happens, the system will detect it. And it will flag your index as, this index is not valid because it was created on the wrong version of the collation that's available. So your system will now run as unindexed, but at least it will not return the wrong data, which is really the most important part. So this gives us both more flexibility and more stability throughout these things. So just as an example from my own country, this is the standard Swedish collation by the names that ICU use, and I have a small table with test data, which sorts them like this. These are names, and is starting with V, and then you got the W. Now, Sweden, for a long time, until surprisingly few years ago, the default collation said V and W are the same character from a sorting perspective. In some systems, that's called the phone book sort order, because they're pronounced more or less the same in the language, and like that's how you expect it to do. So if you want to do that in ICU, you just specify this wonderful name for collation, and it will sort them the right way. There are many other such examples for other languages. And you know, as we all deal with international data, this is a much more complicated problem than most people realize. People like me who are up in Scandinavia, in Northern Europe, we have much more of these problems than you guys have in the US. And we are still easy off compared to some countries and some languages and some sub-languages. Like, this is a really complicated problem. This provides a lot of infrastructure for making that easier to work with. So let's drop out of the SQL Exposed Features and take a look at some of the things we've done through backup and replication. I'm going to start with my own feature because I've been fighting for this for many years and I finally got people on board with it. We've changed the default configuration of Postgres so that you can take a backup without restarting the system. We've done this by changing the default while level to replica. If you're one of the very, very few people who prefer the small performance optimization of minimal over the ability to do backups, then you will just have to change it back to minimal. We've changed the max while sender's default value from 0 to 10, and we've changed the max replication slot values from 0 to 10. We've also changed the default pghba.conf to allow replication connections by default. It allows them from the same sources as regular connections, which is localhost. So it's not like we open it up to the world. But in 9.6 and earlier, we allowed regular connections from localhost, but not replication connections. These changes together make it possible to run PG-based backup and run these commands on your system by default. We've added support for something called temporary replication slots. Because replication slots is this awesome feature that you should probably all be using, but try not to make the mistakes that you can make. Active replication slot will prevent Postgres from recycling transaction log that's older than what that replication slot needs, which is excellent when you have a replica or when you're doing your backups. The problem is if you create a replication slot and you use it and then you stop using it and you forget to delete it, Postgres will just stop recycling transaction log and just run you out of disk. In particular, when you're doing a base backup, you want to create the replication slot, you want to run the backup, and then you want to delete the replication slot. And if you forget this last step, I've seen people end up with like 10s or 20 replication slots that are just dangling that nobody's using. The idea behind this feature is then you use a temporary replication slot. So if the network drops out from your backup, for example, the replication slot is automatically deleted because you're supposed to restart. Now, if your downstream is a replica, if the network drops out, you expect it to come back. Therefore, you want the replication slot to stay around. But if your downstream is a one-off thing, like running a PG-based backup, you really don't want that to happen. You want it to go away because you may not even know the name of the slot anymore. So this one prevents fall behind of your replicas or your downstreams at much less risk than before. Enough that we've changed the default here in PG-based backup to use one of these temporary replication slots by default. It's also changed the default to enable while streaming by default, which means that if you just run PG-based backup in 10 with no other switches, you will get a backup that's complete, and you're good to go. Previously, you needed log archiving, all that stuff. A requirement for this is to be able to support while streaming in tar mode. On the replication side, we now support quorum-based synchronous replication. Basically, you can specify that I have, this is the syntax. You say I have my 4 servers. Any 2 of them needs to have received my transaction for the replication to be considered complete. 9.6 required would be first, and it would require it to be PG1 and PG2, as long as they were available. If PG2 died, it would be PG1 and PG3. This will just let you say any n number of servers, and then I'm good to go. And of course, the big thing in replication in 10 is logical replication. I'm not going to go into much detail of it because you have separate sessions here that's going to talk about logical replication. But the simple thing, it's based on while and logical decoding, which means it can be much, 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 much faster than if you're using things like Sloaney or Bacardo or Londiste. It supports replication of individual tables or sets of tables. You don't have to replicate your entire cluster or even your entire database. You can set up replication sets. It does exactly what you want, and it's really easy to use, unlike, say, cloning. To do it, like, you create your table, and you say create publication on your master, saying I've got it for this test table. Now I have a publication called testpub that contains one table. Then on your subscriber, you still create the table. We don't replicate the schema. You create the table, and then you say create subscription, connect to the server that's over here, and to this publication. And now you're done. You're now replicating this table. Nothing more to do. Postgres will stop and start processes as necessary to make this work. There are a bunch of limitations. One of the big ones today, I'd say, is we don't have schema replication. So you have to create your table on the other side, and you have to create it right. And bad things will happen if you do alter table at the wrong time. There is no sequence replication. So you really should not be using this for failover. Like, we still have physical streaming replication is the way you do for failover. But this enables a lot of things. And obviously, this will be enhanced in 11 and 12 and 13 as we go. But it is pretty big at this point. We got a couple of things around performance. Who in Postgres today is using hash indexes? OK, good for you. Don't use hash indexes. In Postgres 10, hash indexes are no longer completely broken, which is a good thing. You can use them now. They can give you better performance. There have been massive performance enhancement against previous versions of hash indexes. There are cases where it's better than B-tree. Your default index type is still B-tree. Don't go change that. Hash indexes are available, but they're not the only thing, and they're not necessarily going to solve your problem. B-tree does things that hash doesn't. Hash indexes, for example, can only be used for equality lookups. You can't look for greater than or less than, which you can do fine with B-tree. Funny enough, hash indexes can only be used for equality lookups, but we don't support unique hash indexes. That is just a small matter of somebody writing the feature. But supporting range scans is just not doable on a hash index. So consider them, but really do benchmark your specific use case if you want to use hash indexes. But if you're on 9.6 and earlier and you're using hash index, go fix that bug. Don't use hash indexes in earlier versions. We've had massive improvements of the partitioning support in Postgres. If anyone's worked with partitioning in Postgres before, you know it's not very user-friendly. And it's not very flexible and good. We've done a lot of good things to it. As Simon mentioned in his keynote, there are many things missing. Luckily, they're all being worked on. The core of partitioning is still the same one. It's still the table inheritance with constraint exclusion and all of these things. But it's a lot easier to work with. In particular, the syntax for creating and setting them up is much easier. And you no longer have to write a trigger for telling it where to write rows. It knows, like, if you do an insert, it can figure out where it goes. Previously, if you did a select, it would figure out where it is. But if you did an insert, you had to figure it out. That's been taken care of. It has more limitations. Like, the old system was uber flexible, which means the system couldn't optimize as much. This one will restrict you to types of partitioning, for example. But it will then also be able to optimize based on that, because you can no longer do exactly what you want. Some of those optimizations are there. Most of them aren't there yet. But it's a foundation to build on across a couple of versions. For example, we support range partitioning on single column only. And we support list partitioning. That's it. We don't support hash partitioning. There is a patch in that for Postgres 11. We'll hopefully have it there. But that's what we have. And using it is fairly simple. Just as an example, we create our table. This is range partitioning. You say create table. You got the regular column. You say partition by range of this column. And then you still have to create your partitions, where you say create table. And you add this new that says partition of this one for values from these. And once you've done that, you're done, right? Your inserts, your selects, your updates, it will all work. If you insert into a value that doesn't fit in here, you'll get an error. So we still have use for things like pgpartman that exists externally to make sure your partitions exist and create them and things like that. These are things being worked on, I'm sure. Similar for list, you just say partition by list, and you give it a list of values instead of a range of values. The basic thing still applies. There are a lot of limitations. You cannot move rows, so you can't do an update that would move a row to a different partition. That will give you an error. You can't have cross-partition indexes. You can create indexes on every individual partition, but that means also you cannot have a cross-partition key, like a unique or a primary key across partitions. We can fix that, we just haven't fixed it yet. We don't have partition-wise processing, so you can't do like partition-wise joins. Again, we have patches for Postgres 11 that implement this, they're just not done on time. We don't do tuple routing for foreign partitions, because you can, using this syntax, you can actually say that, oh, this partition here is not a local table, it's a foreign table that is a partition of this table. Like, that still works with this new thing. So you can do really cool things, but as you start doing them, optimizations start being turned off, because we haven't figured them out yet. We're going to figure them out, I'm sure. The other thing we've done a lot of things about performance is more parallelism. Postgres 9.6 introduced parallelism. Most of you probably couldn't use it because it was only useful in very narrow use cases. It required sequential scans, and it would parallelize aggregates, hash, and loop joins. There are a few things we've done here. First of all, in usability, there is a new parameter called max parallel workers. We've separated that from max background workers because we might want to control parallelism individually. And the query string is now visible in the workers, and you can see it in pgstat activity. So again, backend type background worker will get queries, the query that you're running, so you can see exactly what the different workers are doing. But at the core, we do now support index scans to be parallelized. We can do a parallelized regular index scan, we can do a parallelized index-only scan, and we can do a parallelized bitmap heap scan, where we scan the index sequentially and then parallelize the scan of the table. We can now also parallelize merge joins, which means we can parallelize all joins. So parallelization will apply to many, many more use cases. We do need your help to test. In particular, things like the cost model might be off, so we might parallelize things that we shouldn't parallelize. So we need your help, we need your feedback on this. Another thing we have on performance, and the last one I'm going to mention there, is multicolumn statistics. It's been one of the weak points of Postgres. If you're, for example, joining tables or where clausing tables on 2 columns, we could only look at each column individually in the stat system to figure out like how many unique entries you have and the distribution of values. With 10, you can do this on multiple columns. Now, this is not done by default, because to collect statistics against every possible combination of columns in your database would be an insane amount of statistics. So you will have to identify which combinations of columns you're interested in, and then you run this new command called create statistics. So you'd say, in this case, create statistics test stats on B, C being the columns from test. So if you run this, Postgres will collect the statistics on the combinations of B and C in the table test, and use that for any query that uses the column B and C. Now, the way it is now, we connect dependencies, so it'll figure out if there is a functional dependency between B and C in this table. And it collects n-distinct, which is how many distinct values, like is this combination unique versus almost unique, and things like that. These are, today, the only extended statistics we collect. But again, this is a framework where we will be collecting more. So that's a lot of features. There's always more, but there's not more time. So I'm going to have to stop at this point. There are lots and lots of smaller fixes. If there are people in the room who wrote the patch for Postgres that we included, I'm sorry I didn't mention it. There are many performance improvements. You can't go through them all. But check it out. We do need your help. I'm not going to go as far as say we've done all our work. We've done much of our work. There is a product out there. You can run the beta version. You can start testing. We do need your help with testing. Apt packages are available, RPMs are available, YUMs available, Windows installers are available, Mac installers are available. You no longer, as we switched into beta, you no longer have to download the source and build it yourself. You can just install it. And again, if you have a system where you have tests, take your application, run your tests against Postgres 10. That will help us, because you might find bug, you might find performance regressions, all these things, and everything is much easier if we find them now. And by all means, if you run Postgres 10 and realize, hey, my test just ran twice as fast as they did before, we're interested in knowing that. We're also interested in knowing why they did that. But even more so, if they run twice as slow as before, then something is wrong, right? It might just be a default value that's wrong somewhere. But you guys have access to many more systems than we do. So please help us out by downloading this, by running tests, and letting us know how it works. Once that is done, we are planning a release. It's not going to be that far away. So now is your last chance to test it before we have to make an actual bug fix release. That's it for me. As I said, there are many more features around. There are a number of talks throughout this conference that will outline this. There is a talk on the logical replication, for example. I don't think we have a talk on the parallelism and partitioning, which is common ones, but There are more talks around it. I'm out of time, but feel free to grab me. And I'm going to be around for most of the conference. Just grab me in the hallway if you have any questions around it. And thanks for showing up.